Hello and welcome to lesson 6F. I can use the appropriate ratios to find area, perimeter, surface area, and volume of similar figures. I want to start by looking at a case study of two similar figures and fill out everything we know about their measurements, and then look for some commonalities here. So in this example, I've got two similar right triangles. I could do Pythagorean theorem to find their missing sides. So 6 squared plus 8 squared is equal to that hypotenuse, which I would get to be 10 if I worked it out in full. Similarly here, I could do 12 squared plus b squared is equal to 15 squared. When I work it all out, I'll get that b is 9, so this is 9. So when I look at the ratio of their sides, so the sides are in a ratio of 6 to 9 as 8 is to 12 as 10 is to 15, or that means their scale factor is 2/3. So now let's look at the perimeter. The perimeter of my small triangle is 6 plus 8 plus 10, which is 24. Whereas the perimeter of my larger triangle is 9 plus 12 plus 15, which is 36. Now let's look at area. Remember, area of a triangle is 1/2 base times height. So area of my small triangle is going to be 1/2. The base is 8. The height is 6. When I work that out, I get 24. And then of the large triangle, we would get 1/2. The base is 12. The height is 9, which gets me an area of 54. So let's take a look at the ratios of their perimeter. Well, the perimeter, the small triangle has a ratio of 24, while the large triangle has a perimeter of 36. When I reduce that ratio, 12 goes into both, I get 2/3. Well, that, if you notice, is the same as the scale factor of 2/3. But the areas, on the other hand, when I look at the areas, my small triangle has an area of 24, my large has an area of 54. When I reduce those, I get a ratio of 4/9. So if you look, 4/9 is really the scale factor 2/3 squared. So the overall conclusion is, if we have two similar figures, the scale factor of a over b, then the ratio of their perimeters is the same, it's a over b. But the ratio of their areas is a squared over b squared. This is the big idea for this lesson, guys, right in this box. So let's do some examples. Miss Rob is enlarging photographs for her wall. She wants the side length of the new photo to be 3 times the length of the side length of the old photo. How many times larger is the perimeter of the new photo? How many times larger is the area? So let's just draw a little picture here. I have an old photo, which we say would have side length x, and my new photo would have side length of 3x, because it's 3 times as big. Well, my scale factor, new to old, would be 1/3. Whereas my area ratio, or let me actually back up, my perimeter ratio, we're starting with perimeter first, right? My perimeter ratio is the same. It'd be 1/3. So my perimeter, the new perimeter, would be 3 times larger. But my area, on the other hand, the area ratio is my scale factor squared. It'd be 1/9. So my new area would be 9 times larger than the original photo. So let's do another example. Two similar triangles have side lengths of 4 inches and 5 inches respectively. The larger triangle has an area of 100 inches squared. What is the area of the smaller triangle? I'm going to draw a little picture, not that I really need one, but I think it helps. So I've got a triangle side length of 4, triangle side length of 5. I know that their sides are 4 inches and 5 inches respectively. Therefore, their scale factor, a over b, is 4/5. I am interested, though, in the area of my smaller triangle. Well, area is a squared ratio. It's a squared over b squared, which in this case, I'd square this 4/5 to get 16/25. And now when I write my proportion to find the area of the other triangle, it tells me the larger triangle is the area of 100. I'm going to use 16/25 to figure it out. I put the 100 on the bottom because I had the larger number on bottom here, so the larger number goes on bottom here. And then the 16 goes on top because it's the smaller, x goes on top on the other side. So I'm doing small over large still. I'm going to now cross multiply, just like we were doing at the very beginning of this unit. So I get 25x equals 1600. Divide both sides by 25. And when I divide 1600 by 25, I get that x equals 64. And this is area, so my answer would be 64 inches squared is the area of my smaller triangle. All right, so that's two-dimension similar areas and perimeters. Let's look at three dimensions. So in this picture here, I've got two square prisms, okay? Where if we look at the ratio of the side lengths, we've got side lengths of 2 to the 4, side lengths of 2 to 4, and side lengths of the height are both 3 to 6, which means that my scale factor here is really 1/2. That's the ratio between them, 1 to 2. So let's go through and fill out all of these boxes over here. I want to find the perimeter of the base. Well, the base is a square. So 2 plus 2 plus 2 plus 2 is going to get me 8 for the small. And then 4 plus 4 plus 4 plus 4 gets me 16 for the large. Now let's talk about area of the base. Area is side squared. Well, side squared, 2 times 2 gets me 4. 4 times 4, on the other hand, gets me 16. And now let's talk about the surface area. If you recall, surface area of a prism is 2 times the area of the base plus perimeter of the base times the height. So if I'm going to do the surface area of my small prism, we already found the area of the base. That's 2 times 4 was the area of the base. We found the perimeter of the base was 8. And then the height of the base is right here. It's 3. And when I work all that out, I get that my surface area here is 32. And so now let's do surface area of the larger prism. Well, 2 times the area of the base we found before was 16, plus the perimeter of the base was also 16, times the height on this one is 6, and when I work all of that out, I'm going to get 128. So here's 128 is the surface area of my larger prism. Now let's talk about volume. Volume is area of the base times the height. So volume of my small prism, the area of the base of the small prism is 4 times the height was 3, we get 12. Whereas the volume of the large prism, the area of the base was 16, and then the height was 6. When I work that out, I get 96. So we have 12 and 96. Now let's take a look at the ratios here. So the perimeter, when I do 8/16 of my two perimeters, small over large, I still get 1/2. That's the same as the scale factor from up here, right? I'm comparing all this every time, not what I want, back up here to that scale factor of 1/2. Well, that's 1/2, it's the same. If I look at the area of the base, that was 4/16, which is 1/4. If you look, 1/2 squared is 1/4. So my perimeter and area are the same ratio as they were on the previous page when we were just talking about two-dimensional area. And then surface area, if I do 32 over 128, that actually also reduces to 1/4. That's still a squared relationship. But my volume, on the other hand, if I do 12 over 1 over 96, that becomes 1/8. 1/8 is 1/2 cubed. So the corresponding, so if I have a scale factor of A over B, then the ratio of the surface areas is a squared over b squared, while the ratio of the volumes ends up being a cubed over b cubed. Here's the cool thing, guys. What power you raise a over b to is directly linked to the units. So if you think about units, perimeter would just be in inches. So we're dealing with a over b. Area is in inches squared. So we're dealing with a squared over b squared. Surface area is also in inches squared. Again, a squared over b squared. Whereas volume is in inches cubed. So we're doing a cubed over b cubed. So there's a relationship between the type of units you're using and how you're going to alter the ratio to help you solve problems with similar figures. So let's take a look at a couple of examples. My first example, there are two similar cones, one of which has a volume of 250 pi feet cubed, the other with a volume of 432 pi feet cubed. What is the scale factor of the smaller figure to the larger figure? Remember, guys, scale factor is simply what is a over b. And then what is the ratio of their surface areas? Well, surface areas is a squared over b squared. So we've got two different things going on here. So let's start with volume. We've got two volumes, 250 pi over 432 pi. These are volumes. If I plug that, my pi's cancel. And if I plug 250 over 432 into my calculator, and guys, use your big fancy calculators for this lesson, you will thank me. 250 divided by 432, your calculator will auto-reduce it to 125 over 216. So I'm coming back over here. That's equal to 125 over 216. This is volume over volume, and volume over volume is an a cubed over b cubed relationship. I really want to find a over b. So what I need to figure out is what number when cubed makes 125 and what number when cubed makes 216. Now you haven't learned this yet, but you will learn it in Algebra 2. There's a button on your calculator way over here. Do you see that the nth root of x button? If I hit Control and nth root of x, it will tell me, it'll take the cube root of a number. So for example, if I want the cube root of 8, that's 2, because 2 to the third is 8. So it undoes a cube. So if I want to do, for example, the cube root of 125, which I need in my problem, which is 5, and then the cube root of 216, cube root of 216, I get 6. So that means that 5 cubed gets me 125 and 6 cubed gets me 216. So undoing this over here, a over b, when I take the cube root, just ends up being 5 over 6. That's my scale factor, 5 over 6. And now that I have my scale factor, I can find the ratio for the surface areas. The ratio of the surface areas must be a squared over b squared, or 25 over 36. So that is my answer, the ratio of the surface areas. All right, let's do another problem. In number 2, a cylinder is similar to a larger cylinder. The scale factor is 1/3. The surface area of the smaller solid is 30 pi, and the volume of the smaller solid is 24 pi. What are the surface area and volume of the larger cylinder? All right, I like this problem because it actually gives me a over b as 1/3. I know a over b is 1/3. But I want to find two other things. I want to find the surface area of the larger cylinder and the volume of the larger cylinder. Well, surface area is going to require a squared over b squared, which in this case would be 1 squared over 3 squared, or 1/9. So I'm going to set up and say 1/9 equals another ratio. I know that the smaller solid has a surface area of 30 pi. Because it's smaller, it goes on top, since the one's on top on the other side. And I'm hunting for the larger. Put an x in the bottom because I'm doing small over large. I cross multiply, I get x equals, when I cross multiply, 9 times 30 gets 270 pi. So my surface area is 270 pi units squared. Now let's do volume. Volume as a concept is a cubic concept, so I need a cubed over b cubed to be volume, which in this case is 1 cubed over 3 cubed, or 1 over 27. So I would set 1 over 27 equal to, and I need to figure out what goes where in this ratio. They tell me the volume of the smaller cylinder is 24, so the smaller number's on top in my ratio, so you do 24 pi over x. Cross multiply, 1x, or just x, equals 27 times 24 pi, which when I work that on my calculator, gets me 648 units cubed for the volume. That's right there, volume. And we're done with that question. All right, let's look at number 3. The volumes of 2 cylinders are 3,250 meters cubed and 702 meters cubed. If the surface area of the smaller cylinder is 504 meters squared, find the surface area of the larger cylinder. So my goal is to eventually find surface area, but I'm given 2 volumes. So in order to work this problem, I have to find A over B. And I cannot find A over B until I find A cubed over B cubed, because they gave me 2 volumes. So I know that A cubed over B cubed must be the ratio of these 2 volumes, 3,250 and 702. I'm going to plug those into my calculator real quick and see if that reduces. 3,250, 702 is 125 over 27. That is 125 over 27. So that means A cubed over B cubed is 125 over 27. I need to figure out what A over B is. And in order to do that, I have to cube root both these numbers. What cubed makes 125? We did this a little bit earlier, but just for some more calculator practice, I do the cube root of 3 third root of 125 gets me 5. Similarly, I know I've got 27. The third root of 27 gets me 3. So this ratio ends up being 5 over 3. That's A over B. But I want surface area. And surface area is a squared concept, so I square both. I do A squared over B squared, which I square this, 5 squared over 3 squared, which is 25 over 9. So that's the number I'm going to use in my ratio. 25 over 9 equals another ratio. They tell me the surface area of the smaller cylinder is 504. My smaller number's in my denominator on this ratio, so I need to put the 504 in the denominator on this side. Put x here. I cross multiply. I get 9x equals 25 times 504. I'm going to divide both sides by 9. And I'm going to do that in my calculator. 25 times 504 divided by 9, and we get 1,400. So that x is 1,400. That means the surface area of the larger cylinder is 1,400 meters squared. All right, guys, thank you very much. Take a look at the MML, and we'll see you in class. Thank you.